Hello, we are discussing about GATE 2013 ECE paper. Look at the diagrams. There, one is delta connection of resistors, the other is equivalent star connection of resistors. Okay, if all the elements in a delta connection are scaled by k, where k is greater than 0, then what happens to the elements present in star? By how much amount it will be scaled down? Okay, so that we are going to calculate. Scaling means, always you may think that when scaling means, let us assume RA, if it is scaled by k, what is the meaning of this one? Is it k times of RA or RA by k? Which is right? First you must get a clarity over here. If RA is the element in the delta network, then if it is scaled by k, okay, then it is multiplying by k, it is not dividing by k. Remember this one. Okay, whenever it is given by scaled down by a factor, scaled down, that is nothing but you are scaling it to reduce the value. By that time you can take it as RA by k, and if it is simply scaling, at that time it is multiplying with k. This you can ensuring by going through scaling property. If you are going for the scaling property of either Fourier transform or Laplace transform, okay, so you are going to say it as g of at, that is nothing but scaling in time domain by a. Scaling in time domain by a is nothing but simply time domain is multiplying with a. Okay, that is what scaling property. Okay, so here also, if all the elements in the delta network are scaled by k, that is multiplied by k. So what factor? The resistors in star network, equivalent star network, will be gets multiplied. So we know the transformation between star to delta and delta to star, which is very well known to everyone. So this is the equivalent star network for the given delta network. Okay, this is delta network. It is also called as pi network, because this is delta and it is looking like a pi. Okay, both are same only. And this is T network, or it is called as star network. This is called as T network or Y network. Okay, T network or Y network, whereas it is called as star network, whereas it is called as pi network or delta network. Now these are the relations between star to delta and delta to star. Okay, now if all the elements in the delta are multiplied by k, that is factored by k, then it will be k times of RA, k times of RB, k times of RC. Then what happens to the equivalent resistances in star? Okay, so R1 is equal to k into k, it will be multiplied with k square, whereas everything is going to be multiplying with k, so you can take it as k common. So k and this square will get cancels. So whatever the previous value, okay, that will be multiplying with k now. Similarly, previous value is multiplying with k. Previous value is multiplying with k. Okay, so if you are going with this is a new value with star, then new value is nothing but previous value times of k. So all the elements in the corresponding star equivalent will also be multiplied by k, that is scaled by a k factor. Okay, so similarly you can also think what happens if all the elements in the delta connection, all the elements in the star connection are scaled by k, what happens to the elements in the delta connection? Okay, so if each is going to be multiplying by k, that is scaled by k factor, then it is k into k, k into k, k into k, that is again it is k square by k into the previous value. So again it will be scaled by k. So the answer is going to be B, whether you are converting delta to star or star to delta. Okay, so the right answer for this question is B.